Is anything not correct in this picture? See, all area need to be connected to the backbone, area 0. Okay, so what do we see here is area 3, which is supposed to be connected to area 0, is not connected. What is the problem then? The problem is the routes of area 3 will not go to area 2. Why? Because there is no area 0 in the middle. I repeat again. In the beginning, I told you area 0 is the transit area. So if an update from area 3 should, if an update from area 3 need to go to area 2, without transit area, it is not possible. Area 0 is the only transit area. Area 0 is the only transit area. Yeah. So because you don't have area 0 in between 2 and 3, updates are not going to go. So what is the option? You need to somehow connect area 3 to area 0. Somehow, what are the ways? When we say somehow, this can be one of the how. Connect a wire physically to this router. So area 3 will give routes to area 0, and area 0 will give it to area 2. Area 1 will give to, sorry, router 1. Router 1 will give to router 2. Router 3 will not give directly to router 2. You know why? Because the updates of area 3 will be only given to area 1 neighbor. Sorry, what am I saying? I don't understand. R1, area 0, correct. Only to area 0 neighbor. It won't give to area 2 neighbor. So when it gives to router 1, and router 1 only can give it to router 2. Is this a nice idea? No. Is it a nice idea? No. But to avoid this, what you should do is you should try to connect area 3 directly to area 0, like we usually used to do. Put 0 here, 2 here. That is how it should be done. But unfortunately, connecting a physical wire between R1 and R3 is also not possible for you. What will you do? I told you, you connect a wire and form neighbor using this this neighbor address, then neighborship will come. And area 3 can advertise to area 0. That's what I told. But assume that this router 3 and router 1 are very far away. If router 3 and router 1 is very far away, means, maybe this is 10th building. This is first building. So now you need to dig the mud, lay some fiber cables. For that, it will take a long time, no? It will take sometime months in many companies to do this. Approvals, and then a lot of things are there. There is a solution where you no need to dig mud and wait for long. You can immediately form a connection with R1 from R3, which is what called as virtual link. Connection is virtual. Virtual connection, virtual link. Correct. Correct. R1 and R3 is going to negotiate tunnel. And using the tunnel, they will form neighbor. So R3 will find R1 as a neighbor. Same like what we used to have in the physical wire. Same like we form neighbor like this. You can also form using virtual link. What is needed is very simple configuration. This is what you need. You need to know the router ID of the router. Assume this router ID of the router is 1.1.1.1. Router ID of this router is 3.3.3.3. If you know this one, it is more than enough to form neighbor. The command is very simple. You go under OSPF of router 1 and say area 2 is a virtual link. Three dot three dot three dot three. So it means that R1 should use 11111 and negotiate tunnel with 33333. You understand? See, R1 will have type 1 and type 2 LSA to reach this 3.3.3.3 because it is in same area 2. So using that reachability, it can go and negotiate. Likewise, in R3, what you will say? Area 2 is a virtual link 1.1.1. That's all. Both the side, when you configure, the negotiation is successful. The negotiation will be successful. Correct. It will be delivered to 1.1.1.1 address. When it goes to router 1 is also a member of area 0. Okay, so very simple, but people confuse by putting area 3. It is not area 3. I know you are connecting area 3 to area 0, but in command area 3 will not come. Why? You are trying to make this area 2 as a virtual link. So in the command it should be only area 2. So this is one of the lab that we are going to do. Next is authentication. Authentication type 0 means null authentication. Type 0 means null authentication. Authentication type 0 is null authentication. Authentication type 1 means clear text. Means they are using the password in a plain text to share in all the hello packets. So if someone uses a Wireshark and sniff the hello packet, they can see the password. That's type 1 authentication. That's why we have type 2 authentication. Type 2 authentication is MD5 authentication. MD5 authentication. Type 2 is MD5 authentication. Null authentication, clear text authentication, and MD5 authentication. Right? MD5 authentication is stronger. So it's recommended to use MD5 authentication. But if you say, no, I do not want to spend much process because MD5 is going to consume process. The reason is it needs to generate the hash value. It needs to generate the hash value, which is process consuming one. Then you can go ahead with clear text. Now, type 0 is null authentication. Type 1 is clear text. Type 2 is MD5. What if one side is type 1, the other side is type 0? They will not form neighbor. Because this side no authentication. This side you have clear text. Let's say the clear text is ABC. This is the password. And let's say you have type 2 here, MD5. Password is same, ABC. What will happen? The neighbor will not come up. Why? There's a type mismatch. There's a type mismatch. This router 1 will be expecting a hash value from router 2, but router 2 is not sending hash. It is sending clear text. Router 1 will be waiting with the hash to compare with the incoming hash. Router 1 will be waiting with the hash so that when a packet comes with hash, it can compare it. Sorry, I made a mistake. In R2, it is waiting with the hash, but R1 is sending without hash, which won't match, so they won't form neighbor. Same way, R2 is only looking for a clear text, but sorry, I think this is the mistake I did. I have put the same number, so I'm confusing you. R1 will be waiting without any hash. It's waiting for ABC as a password. But what is coming inside from R2 is a hash value. Even though the password is same, but R2 is not sending password, it is sending the hash of the password. What is a hash? What is a hash? Hash is encrypted. Hash is encrypted. You see, if I don't know that it is encrypted, whatever coming, I'll consider it as password, which will not be matching with ABC. Because the encrypted values are password with mixer of garbages. That is what encrypted. See, what is actually encryption? You take your password, add a lot of things, not just something, add a lot of things, and then the simple encryption, and then you run through a hashing algorithm for that encrypted one and send that to hash. So not just the encrypted one, you are sending the hash of the encrypted one, so no one can decrypt it. If R1 is also type 2, then that will also have the same hash, and hash will match. They form neighbor. All right, so what I'm trying to say is password matching is not enough. Even the type should match. Right? These are the two things that we are going to do. So between router 4 and 5, we are checking the neighbor. Router 4 says, I know a neighbor, and the neighbor is up, and What else do you see here? The neighbor state is happened. It is in full state, full adjacency, right? There is no neighbor priority. The reason is it is considered as point to point. Network type is point to point, so there is no DRBDR, nothing. We learned it earlier. What I'm going to do now is I'm going to configure clear text, plain text authentication. I'm right now on Ethernet 01, which is facing towards R5, correct? The command is IP OSPF network type point. Sorry. Before that, I would like to do the debug. Debug IP OSPF packets. Also, I would like to say debug IP OSPF events. Now, look at this packet, please. You can see here, no authentication, you see? Authentication type is 0. Authentication type is 0. Don't see this type. No, don't see that type, I said. Here you see only the authentication. Okay. This one is hello packet. Message type 1. Hello packet. Okay. Now, this is authentication 0, null authentication. What I'm going to do is, wait, one more debug I want to see. Debug IP OSPF adjacency. Now, what I'm going to do next is, interface Ethernet 01, IP OSPF authentication. First, you need to enable authentication type 0 or 1 or 2. If I simply say IP OSPF authentication, hit enter, it means you are enabling type 1 authentication. No. Type 1 means clear text. So immediately it says mismatch authentication. This bad boy router 5. This router 5 is using type 0, but we are using type 1. See how clearly it is stating, no? It says router 5 is using type 0, but we are using type 1. So mismatch authentication. We didn't even give password, okay? We didn't even give password so far. Let's give the password. IP OSPF authentication is the same command. IP OSPF authentication. Now I have to put hyphen and say key. Okay. Earlier, without a key, we hit enter. Isn't it? Now the password, the key is Cisco 123. Done. Even now also it is the same thing. We are using type 1, the other guy is using type 0. Right, so the neighbor is now gone. You see, earlier we were typing show IP OSPF neighbor 5555. Now you don't see that neighbor. Even if you undebug and make it clean slide. Now you see nothing. There is no neighbor. Show IP OSPF neighbor. The neighbor is gone down. Only with 3 it has got neighbor. There is no neighbor with R5. Now I'm going to go to router 5. And go under interface Ethernet 01. IP OSPF authentication. IP OSPF authentication. But this time here I'm not going to give the same password. I'm going to give wrong password. You understand? I'm going to give wrong password and we will also put the debug in the previous router. Debug IP OSPF events. Debug IP OSPF authentication adjacency. Debug IP OSPF packets. Okay. Now, authentication key. What is the password I gave that side? Here I am going to say my 123. Now let's see what happens. You see, very clear, very, very clear. Last time it was saying mismatch authentication, but this time it is saying what? Both side it is clear text, but what is mismatching? The key is mismatching. Very clear, no? Very clear. Type 1 authentication. Very clear. We can see the debugs are very fine, no? Powerful. Now let me go and give the correct password. What is the password? The correct password is Cisco123. After I say that, I'm expecting neighbor to come up. Look at this, loading to full. Wait, it's gone. Yeah. Okay, let's check one more time this neighbor command. You see, the neighbor is back. So now let us do one thing. On R5, we'll say interface Ethernet 0/1 IP/OSPF authentication. You see, message digest. Before that, I'll go to router 5 and enable debug. This time we'll do a debug on debug IP/OSPF adjacency, debug IP/OSPF packets, debug IP/OSPF events. These are the three commands I always use to debug. I hit enter. Now you see, again the neighbor will go down because of the authentication type mismatch. You see, no, still not come. Here, we are using type 1, but that guy is using what? Type 2. This is not saying mismatch authentication key. This is mismatch authentication type. Yeah, type. So we'll now go and configure interface Ethernet 0/1 IP/OSPF authentication message digest. After I say this, the neighbor should come up. See, loading to full immediately. That's all about the authentication. What is next is the virtual link. So